And welcome back to our very last grade 5-6 problem of the week for this year. It's been my pleasure to be able to work with you and to look at some of these problems and come up with some strategies on how to solve some of these problems that we've been working through during this distance learning. So the first problem for this week starts off with alternate dimensions, and it reads: the four shapes to the right are drawn with a horizontal base and a vertical height. Figure A is a right-handed triangle, as evident by the right-handed symbol. Figure B is an isosceles triangle, again represented by these two marks, telling us that these two sides are exactly the same. Figure C is a square, and figure D is a rectangle. The figures are not drawn to scale. So using the following clues, determine the measure of the base, the horizontal base, and the measure of the vertical height of each figure. And I'm glad that they stated that the base in this case is horizontal, because as we know, depending on orientation of the shape, especially on a square, any of these sides could serve as the base. Same way with the rectangle, any side could serve as the base. Even on the triangles, any side can serve as the base in this case. So, but in this particular one, they're saying that it's the horizontal. So we're always looking at that horizontal one serving as the base. The vertical is going to be the one that goes straight up and down. So in these three shapes, we could pick either side for C and D. For A, it's going to be that one there. For B, it's actually going to be kind of that dotted line running through the middle. So it starts off and it says the measure of the base of figure A is the same as the measure of the base of figure D. So we know that this base here and that base there are exactly the same. The measure of the base of figure A is 1 unit less than the measure of the base of figure B. So we know that this one and this one are going to be 1 unit less than this one. So if this base was, for example, 4, these are going to be 3. The side length of figure C is the same as the measure of the base of figure A. And so we know that all 4 sides in this for the square are going to have exactly the same measure as, again, the base for A and the base for D. The measure of the height of figure B is going to be the same as the measure of the height for A and the same as the measure of the base for B. And so what they're saying here is that height of B is actually the exact same number as the base, which we know is 1 more than any of these sides, 1 more than this base, 1 more in this base. And they said that this height is the same as this base and that height. Then finally, the area of figure C is 9 square units. And this is a key aspect. This is the actual first number that we have. And because of all these relationships, this is where we're actually going to start in solving this logic problem. And then finally, the total area of all 4 figures is 38 square units. Why would that be important? Because we know this relationship or this number is going to be the same as that number, which is going to be the same as all of these. We know that this height is going to be the same as these and that. And because we know our formulas for finding the area of triangles, we're going to be able to solve this one, solve that one. We know the formula for area of squares, so we can solve this one. But what we don't have is we don't have any relationship related to this side on D. And so that's where number 6 is going to become important. We're going to need to solve these 3 first, eliminate that off of that total number of 38. And then because we have the 1 value on D, we'll be able to figure out the other value for the vertical height for D. And so in this problem, we're actually going to start at number 5. And number 5 says this is 9 square units in terms of its area. So we know that this side is 3, this side obviously is 3, and then we can build it from there because we know we said that this is the same as that. We said this is the same as that. We said this is one more than those. We said this and this are one more than that. And then we're able to solve it from there. So a very interesting logic problem, and one that reminds us that when we're solving word problems, we don't necessarily always start at the beginning. We want to read all the way through the problem and figure out where are my known values, and always start with our known values and solve from there. And so in this particular case, our first known value is actually at 5, and we're going to solve the problem accordingly. So I hope that helps, folks. And remember to look for the solution next week if you are receiving these problems. Thank you very much. Bye.